Hi guys, we've got a different style question today. We've got a BMO question from 2012, this BMO 1, question 3. And it reads, find all real numbers x, y and z which satisfy the simultaneous equations x squared minus 4y plus z equals 0, y squared minus 6z plus 14 equals 0, z squared minus 2x minus 7 equals 0. Now, first thing I notice, we've got three equations, right? First equation has x and y. Second equation has y and z. And third equation, x and z. Right. So we've got an x in two of these equations, y in two and z in two. So we need to find a way to somehow link x, y and z. So how would we do that? Well, since we've got 0 on the right hand side, we could just add all of these to our... Yeah, we can just add all of these. Like such, so we have, let's add all the x terms. So we're literally adding equation 1, 2 and 3. So we add the x terms, add the y terms, add the z terms. Z squared minus, where's our z? 6z. Then add our constant 7 plus 14, 21 minus 7 plus 14 equals 0. Right, now what we can do to simplify this expression, we can complete the square. So for the x, we have x minus squared minus 1. For the y's, we have y minus 2 squared minus 4. For the z, got minus 9 plus 14 equals 0. Let's collect our constants. So we have minus 1, minus 4, and we've got minus 9. If we sum those, we get minus 14. We've got plus 14 in the end, so that just cancels. And therefore our constant term disappears. Now we've got this looking a lot better. We've got x minus 1 squared plus y minus 2 squared plus z minus 3 squared equals 0. Now we know anything squared must be equal to or greater than 0. Now, if any of these brackets were larger than 0, this equation would not hold true. For example, if we had 4 here and the rest zeros, or any other number, there is no possible way we can form a 0. Therefore, if our brackets are not greater than 0, they must be equal to. So x minus 1 must equal 0, y minus 2 must also equal 0, and obviously z minus 3 must also equal 0. So we have x equals 1, y equals 2, and z equals 3. Now we've considered all cases because we looked at when anything squared is greater than 0 or equal to 0. So we can say that this is our only triple of solutions which satisfy the three equations we were given. Not a bad BMO question. Hope to see a few more like these. And yeah, thank you. Goodbye.